Application of filters in Bash scripts. Filters are basically used to remove or extract text from files. There are different filters available in Unix called cat, tag, tr for translation, then sort for sorting, unique for getting the unique contents. But in this section, we'll see how we can use three most important filters in Unix called grep, set, and awk. First, let's see how we can use grep. Open the script called filters underscore grep.sh. Grep is basically used for getting some patterns from a file. Let's first define a file called testlog.log. Let's open the file testlog.log. Here we see it is a kind of log file where different information is printed. We want to get some text from this log file. Let's say test server. Let's define our pattern variable as test server. To check whether a pattern exists in the file or not, we have to write if grep minus q, then $pattern, then $log file. If this condition is satisfied, we can print like echo match found. Otherwise, we do not find a match. Let's try to execute it. We see there is a match found of this pattern. Let's try to print a line which doesn't contain the matched patterns. So we have commented the earlier code. To print all the lines from the file which doesn't match with the pattern, the command syntax would be grep minus v $pattern, then $log file. Here you see the lines which doesn't contain the text called test server is printed on our prompt. Next, we'll see how we can ignore case in the patterns. To ignore case in the grep statement, you have to add the option called -i. This will ignore the case sensitivity in the pattern. We see here all the lines which contains test server is printed by ignoring the cases. Let's say we want to print the line after a matched pattern. The option for that would be minus capital A 1. So it will print one line after the matched pattern. So here is our match line. Then it is just printing the next line after the matched pattern. In the similar way, we can print a line before the matched pattern. So here is our matched pattern, and this is the line before matched pattern. This one represents the number of lines you want to print. Finally, you can try to print all the lines before and after the matched pattern. To do this, you can provide the option -a1 and -b1. This will print lines before and after the matched pattern. So here you see this is our matched pattern, and the line before and after is printed. In this way, you can use different grep options in the scripting. In the next lecture, we'll see how we can use awk filter. Awk and sed are a special type of filters which can be treated as a separate scripting languages. They have their own extensions, but in bash scripting, we'll use their features for file manipulations. Let's see what we can do with the awk filter. We'll be reading a file name, then we'll try to print the entire contents of the file. To do that, the command is awk within quote and within bracket print, then $file name. It will print the contents of the file, test file. So the entire contents of the file, test file, is read. So next we'll try get some patterns and print the line which matches those patterns. So how we can do this? Awk within quote slash will be matching a pattern called root, then print that. File name, give a file name. So here see all the lines which contains the pattern root is printed in our terminal. Now let's try to print the specific column in the matched line. To do that, the awk command would be awk or matching pattern within slash. Then within the print statement, we'll be printing $3. It will print the third column in the matched line. The third column in the matched line is the directory. We just print out that field. We can also provide different field separators, but the default is the space one. We can also print n number of columns from the matched line giving variables $2, $3, $4, etc. So this will print all the respective columns. Here we see the second and the third columns are printed in the matched line. There are many more options available in the awk. So you can use or explore those options and write the scripts. That's all about awk. Next we'll see shade filter. Shade stands for stream editor. Basically we can process, manipulate or get patterns from a file by giving a stream of text through a file. Whatever operations done using awk, that also can be done using shade. Let's see some pattern matching operations using shade filter. We'll try to find a pattern in the file name called root and we'll replace that pattern with another text called groot. So to do that, the command is shade within quote S for substitution, then slash the first pattern, then slash the replacing pattern, slash, and after that the file name as input. Let's try to execute this. Filters underscore shade.sh. Whatever patterns in our file is root is replaced by groot. But one thing you will notice, in every line the first pattern is replaced, the second one is not replaced. So this command basically tries to match the first pattern and replace it. So let's see how we can do the replacement in all the match patterns. To do that, add a option called G for global. So it will do the replacement globally in the file. Here we see all the roots in the file are replaced by root. These replacements doesn't affect the file directly, it is just printing in the prompt. In order to do the replacement directly in the file, we have to give the option shade-i, then whatever replacement you want to do, then file name. It will match the patterns in the file and replace those within the file itself. These are some basic options of shade. There are many more features available in shade. We can explore and use in the scripts. This brings to the end of this chapter. Let's summarize what we have learned in this section. In this section, we have learned some basic application of different type of filters available in Unix. We have learned some introduction of grave, awk, and shade filters and how we can use them inside our scripts. This brings to the closure of this module. In the next module, we'll see some application scripts.